Hello and have a good day. Today, me and my team will be present from assignment that asks us to create a circuit and find their voltage across the resistor, and also to find the voltage output. And the last one, we will be find the waveform from this circuit. So firstly, my name is Zulhelmi. I will my my job is to be a moderator for this video, and Ilya will Ilya will
They
conduct
construct the
the
circuit.
uh, will construct the circuit, and Vina be as a support for Ilya. So the first task that we need to do is we need to construct a circuit from the questions. The question already gave us the circuit. So we just copy and paste everything that given to us. So Ilya, can you show how to construct it? Okay. What we need here is the power supply, where this power supply is a 5 volt, and we need three type of resistor, which is R1, R2, and R3, where the three of this resistor has a different resistance. R1 is R1, the resistance for R1 is 200. Resistance for R2 is 300, and resistance for R3 is 150. At the same time, we have a capacitor on this circuit, and the value for this capacitor is 1 millifarad. Okay, now Ilya is put the value for each component on this circuit, and after complete insert the value, we will place the position where we must find the voltage, the current, the voltage and the current. So the first point we put is before the resistor 1, and the next point we put is at the junction between R1 and also R2, and the third point we put at the junction from R1, R2, and also R3, and the last point we put is before the capacitor, which this will be as a V output, and the point where before R1 is the V in. After we finish these constructions, we will run. We will run the DC solver, and yeah, you can click it. And after we can we click one by one point that we already put, then we got the value for V in is 5 volt, V for node 2 is 1.667. It is same also for the node 3, and also for the node for the V out. This happen, the three nodes have the same voltage because this because of the parallel on the circuit, and for
Sekejap.
this, yeah,
Continue.
okay, because of the parallel on the circuits where the voltage is same even in different points. So For the we already uh, gain we already gain the value for V in V for V not 2, V not 3, and also then for the next question, they ask us to find the out already got, and the okay we back to the questions of two Romans, where it asks us what is the relationship between the output voltage and also resistance. Due to Ohm's law, we know that V equal to IR. Here state that when the voltage increase, no, when the resistance increase, the voltage also increase. So the relationship between the output voltage and the resistance is the directly proportional. So we already answered these questions. For the next question, they ask us to find the V out using the DC solver, and we already use it, and we got the answer for V out is 1.667 volt. And for the questions number 4, they ask us to predict what is the V output when the R2 and the R3 is connected in a series. So when they ask us to predict, the way we do it, the way that we predict is we calculate it manually. And Ilya, can you show the calculations that we already done? Okay, this is the manual calculation from us to find the voltage output when the R2 and R3 in a series. So what we got is what is the answer? Wow, 1.667, right?
Yes.
Can you scroll down? No, okay. The V output that we got is 3. Okay. Before that, we
No,
will
no, no.
let Ilya construct the circuit first. Okay. As we know that the question asks us to create in a R2 and R3 in a series, but it doesn't mention about the R1. So we can conclude here that R1 also in the series Uh, and after we create this, we just have three type of points to find out, where V in is the first point, V not 2 is the second point, and V out is the third point. So then after we done, we run DC solver, and we got the V in is 5 volt, V not 2 is a 3.62, and the V output is a 3.462. And this show that from the DC solver and from the manual calculation that already done by us is has the same answer. So we think that what we already done is correct. So for the next questions, I will give Wina to conduct.
Okay, for question number 5, this question want to determine the input and output waveform when the value of capacitance is changed. Okay, now we continue with question 5. This question is to determine the input and output waveform when the value of capacitance is changed. So Ilya will show how to construct the waveform when the time stop is set at 10 ms and the time steps was set at 20 microsecond. Okay, first capacitance is 5 micro Okay,
milli.
now 5 milli. Okay, now okay, this is for input waveform, and for output okay. So this is for output waveform for capacitance 5 milli F. Okay, now we continue with capacitance 1 micro F. Okay, looks like same as 5 milli F, and we look for output. Okay, this is output. The waveform actually is quite same. The pattern is same. And now for 0.1 micro. Okay, this is input waveform, and the next okay, output waveform. And now capacitance for 1 nano. Okay, this is input waveform for 1 nano F. And output waveform. Okay, the last one is 0.1 nano F.
This is the last eh?
Yes.
Nano.
Mm-mm.
Oh,
Okay,
need output.
so this is output.
Hmm.
Okay, this is output, and we look for input. Okay. Okay, this is all the waveform that constructed for 5 capacitance. And now we look at the next question is explain the relation between the waveform signal and the value of the capacitance. Okay, based this question, I can explain that based on formula of charge, which is Q equal to CV. So this formula we can rearrange for capacitor equal to Q over V. So we can know that when capacitance is increased, voltage become decrease. So C is inversely proportional to the V. So from the question, uh, This question want to relation between the waveform signal and the value of the capacitance. As we know, the waveform signal decrease because of voltage. So here we can conclude the waveform is actually the voltage. When the waveform increase, means that the voltage increase. So when voltage increase, the capacitance decrease. Okay. So this the answer for this question.
When waveform increase, voltage decrease.
Yes.
Capacitance increase.
Capacitance voltage increase, capacitance decrease.
Hmm.
Okay.
Done.
Okay. That's that's only our presentations for the group assignment electronic simulation via the circuit. Yeah. Thank you.
Thank
Thank you.
you.